Okay, let's get going. All right, so hello everyone. Thank you for joining our HashiCorp Solutions Engineering Hangout today, hosted by Yash. Today we're going to mainly talk about HashiCorp Terraform and Consul. HashiCorp Terraform uses infrastructure as code in order to provision any cloud infrastructure in service. HashiCorp's Consul is a networking platform that allows you to connect and secure services across any runtime platform on a public or private cloud. So Terraform allows you to define your infrastructure as code, variables, and modules empower you to extend and reuse your infrastructure as code. Yash is going to talk about using the Consul provider for Terraform, so your Consul KV data drives your Terraform runs. I also want to note that the Hangout is being recorded, and the recording will be made available to you after post-processing, usually within a day or two. So I'll email that out to all of you. The demo will be about 25 minutes, and then we'll allow up to 30 minutes afterwards for questions. So please, throughout the demos and presentations, submit your questions through the Zoom Q&A portal, and we'll answer them at the end. So with that, let's go ahead and get started. Take it away, Ash.
Thanks, Brianna. So before we jump in, just real quick, I hope, I know we're in some interesting times right now. I hope that you're all well, that your families are well, and thank you for taking the time to join us today. So why did we want to talk about Terraform and Consul? As Brianna was describing, you know, what is happening today is we're in the midst of this generational transition, right? If you look at about 20 years back, you know, we were moving from traditional micro computers, you know, physical machines to VMs, whether it was with VMware or something else. Today, that transition is to the cloud, right? We're modernizing our traditional data centers, making them so that we can adopt a cloud operating model, even on-prem, right? And of course, leverage public cloud to the best of our abilities. And what that means is, you know, the approach we took in our traditional data center that often for enterprises was ticket-based, right? You'd put in a ticket to request infrastructure, you'd put in a ticket to have it racked and stacked, perhaps, to get it OS, if that was done by another group, to get, you know, network firewalls and so on and so forth. And it took about 3 months, you know, to get that machine that you were requesting finally connected so that you could put your application on it and make it available to your end users, right? And the manner in which we're working, the value of public cloud doesn't translate well if we keep those traditional approaches. So what that means for us today, you know, like everything else, we break it down into people and process and finally technology. So from a people perspective, you know, the roles really haven't changed, right? You have your traditional operations group that is responsible for provisioning infrastructure. Today, rather than, you know, dedicated physical or virtual machines in a traditional data center, we want to have elasticity in our workloads so that we make good use of those resources. We're not, you know, running at what we require for peak demand because that's just expensive, right? It's not good use of resources. Similarly, the way we approach security, the way we do networking, the way we you know, provision our services, the way we schedule our services also needs to change. I'm not going into detail on that. We can do that at another time, but I'd like to focus today on the provisioning piece of it, right? If you look at how we do provisioning in this brave new world, you know, certainly you have cloud native solutions. So on AWS, that might be CloudFormation. You have ARM templates in Azure and you know, so on and so forth. What that means is developing expertise that are specific to that platform, that when you try to adopt a different cloud platform, right, it means learning a new set of technologies. It means, you know, ramp up time. So what that creates is it creates lock-in, right? Where if I'm on AWS today, and that's where a lot of us start out. If tomorrow there are solutions on Azure, excuse me, I clicked the wrong. There we go. So there are resources for which we want to adopt Azure or Google Cloud, or maybe we're a multinational and we're need to do business in China and Alibaba Cloud makes sense and so forth. It increases our learning curve. So what we've done across the provisioning layer, as well as each of the other layers we've spoken about, security and networking and orchestration, is we've tried to provide tools that are not specific to a particular cloud environment, that are not specific to a particular platform, that work across these clouds, right? So whether you're using AWS or Azure or something else, you can use Terraform to provision across all of those. So when we talk about defining our infrastructure as code, which is what Terraform does, the idea is that we want to create, as Brianna was describing, definitions that provide predictable results, so that when our application moves from dev to QA to stage and finally production, that we're not having to recreate. We're not having to go into a GUI. As great as the AWS and so forth, the GUIs are, when you go into this GUI, when you go into this web UI and you're pointing and clicking, to do that in a consistent way, it's hard to reproduce consistently, right? So the approach that Terraform takes is it lets you define, using the HashiCorp configuration language, or HCL, your infrastructure as code, a declarative definition of what our infrastructure should look like, whether that is the cloud layer, whether that is our networking, whether it is some platform that runs on top of it, software that runs on top of our platform, and so forth. This is all done through providers. There are over 200 providers today that let you provision resources through Terraform across these clouds and across different platforms. The next natural question that arises is, okay, I'm defining my infrastructure as code. How do I scale the use of this approach in my organization, right? How do I drive down that time from 3 months to literally minutes, where I can have the resources that I require available and taking traffic, right? So Terraform has also, as a part of it, a governance, the idea of defining policy as code, right? Just like we define our infrastructure that we want to provision as code, we have the Sentinel policy language that lets you define the policies with which you must comply when you're provisioning resources. So when you then go to adopt Terraform as a self-service infrastructure, as a shared service within your organization, you know that what is being done isn't going to harm the organization, right? So let's say that we have an operations group that has been writing Terraform code, writing infrastructure as code, and now we're adopting this throughout the organization. Through reusable modules in a private module registry, it allows other practitioners, developers, network administrators, database administrators, and so forth to come in, make use of those modules, and very quickly provision resources, right? And it also allows them to write their own Terraform code. And in both cases, whether they're making use of modules, whether they're writing their own Terraform code, that code must comply with the policies that are defined. The result is, rather than going through a long change management process, where a change review board maybe, allows or denies some change to go through, that is eventually translated through policies, where the policy checks and says, yes, what you're doing in terms of maybe you're opening up in a security group some CIDR blocks, maybe you're provisioning a piece of compute that's of a certain size for a certain environment and so forth. Through the policy definitions we have that, yes, this should be allowed, or no, this shouldn't be allowed. So when we talk about defining our infrastructure as code, right, there is a question of, well, how do I make my code reusable, right? Just like any language, we want to write modules, we want to write functions where our code is reusable, right? And we can instantiate that code in different ways. One way is through Terraform variables. Another is through resources that are provisioned. Those resources have outputs and you can consume those resources. Another is if you have resources in your environment that have been provisioned outside of Terraform. Those are what we call data sources in Terraform, and you can source that in your Terraform code. Another is remote state. So when we talk about a piece of Terraform code, we call that a workspace, right? And a Terraform workspace is a logical composition of your infrastructure as code. And when I say logical, I mean, think about the life cycle of what it is you're provisioning, right? What will you provision together, modify together, and perhaps eventually destroy altogether, right? So you have, in making a service available to your customer, you have several things that go into it. In AWS terms, a VPC, subnets, security groups, security groups that are enterprise-wide, security groups that are application-specific. You have databases perhaps that are shared and so forth. Now, in terms of what you're doing for provisioning the service itself, all of those are required to make that service available to your customer. In terms of the level at which you'll iterate or who'll be managing those resources, that varies. So this is where you may break up things like your VPC and your security groups that are enterprise-wide into one workspace, and then have things that are specific to the application, perhaps in another workspace, right? And so the concept of remote state is that you can make use of the output from one workspace in another workspace. And then what we're going to kind of double click on today is data coming from Consul. So as Brianna was mentioning, Consul is our solution for doing service discovery, for doing service mesh. It also has a key value store. So it acts as a distributed configuration management solution, right? So as we'll look at today, things you might have defined in some other place you can centralize in Consul. And just like all of our tools, they work very well together, Terraform and Consul, as we'll look at, and also Vault, Nomad. They play very well together. They run great individually as well. But it's great, when you're using Consul as well to be able to make use of that information in Terraform. And then the other thing is Vault, right? So Vault is our solution for security. And when you're dealing with requiring sensitive information in your Terraform run, right? So when I say sensitive information, think of it as a secret, something that enables you to, if you have it, do something at a privileged layer, right? So why put that into Vault as opposed to Consul, as opposed to anywhere else? When we talk about variables, Terraform has a concept of sensitive variables. If you're using Terraform Cloud or Terraform Enterprise, and what that means is that those values are stored, they're stored encrypted, they're write-only, so you can set the value, but you can't read what it is. Terraform can make use of that value in doing its run, right? And this applies for Terraform variables as well as environment variables. That encryption actually happens using the built-in Vault or an external Vault. But you might use Vault for dynamic credentials, as we're going to look at today. So let's say we're provisioning in AWS and we need AWS credentials to do that. Rather than having them even though they can be marked as sensitive, that means that they're longer lived, right? And the idea with the AWS secret engine for Vault is we can get short-lived credentials that have a TTL, a time to live, that is sufficient for a Terraform run. They have a relatively short TTL, and then they expire, and Vault takes care of that for us. So let's look at what this looks like in terms of code. Our variable definitions, if you looked at Terraform code, this should be very familiar. We define the variable with its name. With Terraform 0.12, we have strict typing. So this is an example where our type is string. We can give an optional description, and we can give an optional default value, right? And this can be overridden in our variable definition in our workspaces we'll look at. And then to make use of the variable we've defined, the resource that I'm declaring here, an AWS instance that I'm going to provision, it takes an input of AMI, and I'm saying use var.ami_id, which is the name of the variable we declared above. In terms of resources, so you might have a resource you create, let's say an AWS instance of type web. It's going to result in providing a number of attributes that come back from that. So here we're creating a DNS record, a Cloudflare record. We're calling it web, and we're making use of the value from this resource. So AWS instance, web, public IP, and public IP is an attribute that AWS instance exports. And then you might have data sources. So the difference between using a resource and a data source, as I mentioned before, is where that piece of data, rather than being defined in Terraform in this workspace or in a remote workspace, it has been done actually outside of Terraform. So the prefix is data. The type of data is AWS AMI, and then some value, some name I'm giving it here. And then I can make use of that in here. I'm creating an AWS instance. And so I refer to that as data, AWS AMI, HashiStack, the name I gave it, and then the ID, which is an attribute it exported. For remote state, there's a data type of Terraform remote state. And again, I give it a name. I specify the parameters. So this can be Terraform Cloud, or it can be Terraform Enterprise. But I specify the workspace, and then I can reference that by doing data Terraform remote state, the name I gave it SSH key, and then the output it created, which was called, in this case, SSH key name. So for Consul, right, this is what we're going into today. So for Consul, we have the data type Consul keys, right? And I'm calling it AWS instance. And then I'm specifying here the key name, instance type, which is again just a label I'm going to use to refer to it later on. And then the path within Consul. So here it's been parameterized with some variables, but for example, cloud, AWS, a region name, instance type. And as we look at in Consul during the demo, I'll show you what this maps out to. We can optionally specify a default, right? So if Consul doesn't have this value, to use something that's been defined as a variable, you can use that as well. And then to make use of that piece of Consul KV data, I refer to it as data Consul keys, the name I gave it, which was AWS instance, var, and then the var name, the variable name I specified here, which was instance type. And then for Vault, we can instantiate the Vault provider in a couple of different ways, using a token, or I can use app role authentication. So Vault supports a number of authentication methods. One of them is called app role, which is, think of it as a multi-factor authentication for applications. But we have Terraform authenticate against Vault. And then we can pull a Vault AWS access credentials is the data type, and creds, and the parameters needed to access it. The powerful thing here is this isn't something that's stored statically in Vault. When Terraform requests this from Vault, what Vault is doing is it's actually creating just in time the credentials that are required. And again, those credentials have a time to live. So when that TTL passes, Vault expires those credentials. And then here's the AWS provider making use of that data. So it's data, Vault AWS access credentials, creds, and then what comes out of it, the attributes are access key and secret key. So with that, we'll jump into our demo. Let me exit my presentation. Okay, that worked. Okay. So what we're going to be doing today is I have a Consul cluster running. This is a pretty basic cluster. I don't have anything other than just the server nodes. But you know, your Consul cluster is comprised of server and client nodes. The server nodes are responsible for establishing. They use the RAF protocol to establish leader election, to establish quorum, and then the gossip protocol is used amongst the clients for propagating data. So one of the aspects that Consul has in it is the service definitions, right? So here the only service is defined as Consul, and we see the nodes that comprise it. Then Consul has a KV store, a key value store, right? And this is where we're going to be making use of today. Now, to interact with the Consul KV store, there are three ways to go about it, right? One is using the CLI. So just very simply, in order to put a value, I can do Consul KV put the path. So just as an example, we're going to put cloud, AWS, US West 2, AMI, and then the value, right? And that will write to Consul. Another approach I can take is to do an API call. And here I'm doing a put, I'm specifying the data, and I'm specifying the path. I'm using an environment variable as set to facilitate the communication that returns true. I can also do this through the UI. So I can create a key value pair. I can navigate through, I'll actually just show you what is set here. So what did we set? We set, actually we set US East 1, didn't we, through the API call. Let's look at that. And then AMI, right? So I can enter the value here. If I was creating a value, I could go back up here. I could click create, specify, you know, so for example, foo bar. If I want to create a folder, I put a trailing slash. Otherwise, I put just, you know, the name at the end and then the value here, right? And click save. Now, in terms of what we've just done with our CLI, with our API call, and through the UI, all three of those have done API calls, and this runs through our products, right? So when you interact with Consul, when you interact with Vault, when you interact with Nomad, when you interact with Terraform Cloud or Enterprise, you may be using one of these methods, but underneath it, it's just making API calls. So this is great. I put the value. How do we, oh, actually, I want to show you one more method of putting the value, right? And that is our, through the Terraform Consul provider. So I have here just a very simple, I'm using the Consul provider, and we'll deep dive into this a little more. I'm using the AWS provider. I'm getting some data from AWS, and I'm putting that into Consul, right? Just like we placed the AMI. Here we have the data coming from AWS. So I'm going to create a resource. So it's not a data. It's I'm doing putting a value, Consul keys, AMI, and then the path and value for that key, right? So if I do Terraform apply, Right, so that is going to create this resource. It's called AMI, and then the data is, so the parameters here you see what Terraform does is there are certain things that are known, and there are certain things that will be known after the apply happens, right? So the plan is, when you do a Terraform plan, what it does is it looks at your desired state, what you've declared. It looks at what is out in the environment, and it figures out what it needs to do. So the inputs that we've defined here, they'll be listed here. And then what will come back as a result of the apply, it'll say no after apply. Now, if I don't explicitly do a plan and save a plan, when I do the apply, it does a plan, Terraform does a plan inline and uses that plan for the apply. And I'll go ahead and say yes. And it Terraform has placed that, right? So let's look at real quick what we put there. I can do a Consul KV get to get that data, right? Just like we did a put, we can do a get. I won't go through the process of interacting with the API because you get the concept. The concept is the same. So let's make use of this in some actual Terraform code. So what I've done here, the window at the top right, is we have some Terraform code that we have written. Traditionally, the practice when you write Terraform is you have 3 essential files, right? There's no requirement to do this. What Terraform does is it'll process all files with the .tf extension. But traditionally, we have our variable definitions in variables.tf. We have our data and our resources defined in main.tf, and we have outputs defined in outputs.tf. There's no requirement to do that. I've organized it a little differently just to make it easy for us to go through the different files, the different components we have. So here I'm specifying the version of Terraform we want to use. Here I'm declaring the providers we're going to use. When you look at my console provider, these are all commented out. So I can pass these parameters for the console provider, the address, the scheme, and the data center. But what I have done, this is the workspace that is associated with this code in Terraform. And so what I've done is I've defined some variables that are needed for our run. And for the console provider, I can also use environment variables. So the console HTTP adder, the HTTP SSL verify is set to false because we're interacting. I don't have in the subject alternative name for the cert for this console endpoint, the IP address. And the other item related to console is the HTTP token. It is a sensitive item. It is something that, you know, if you have it, you have privileged access and you can do things with. So I've marked it as sensitive. So the value is write only. I can't see it in my Terraform workspace, but the workspace can make use of that value. So that's my console provider. Similarly, I have my vault provider, and here I'm actually using some variables I have defined. So, you know, the address and so forth are referencing variables, and I'll show you where the variables are defined in just a moment. And then coming from our vault provider, as I mentioned before, are the AWS access credentials. So what we're going to do here is we're going to get dynamically generated AWS credentials from Vault for our Terraform run. One thing you'll note here is I've commented out token, and we're using app role authentication that I was describing earlier with a role ID and secret ID. And then finally, the AWS provider is making use of this data, the dynamic credentials that are coming from Vault. Here, I won't go through all of them, but I have the variables defined. We had looked in the slide earlier at what the variable definitions of the different types look like. Here's a string, here's a Boolean, and so forth. The variables that our Terraform code is making use of. Here's an example of a data resource, right? So in this case, I'm pulling in AWS AMI and I'm specifying some filters for locating that AMI is a AWS machine image. Think of it as kind of, back in the day when you did your Kickstarts or your other way of, provisioning kind of your base image you were starting with. So here's an example of pulling remote state. So my SSH key for access to, we're going to provision AWS instance. My SSH key is going to come from this other Terraform workspace that I'm referring to through the variable name SSH workspace. And the host name refers to my Terraform instance endpoint. If I didn't specify it, it would default to app.terraform.io, which is the endpoint for Terraform Cloud. And here's our console data. So the approach here is, I'll define console keys, give it some name that I can then use to reference it in my Terraform code onward. And then it'll default to this data center, but I can specify another data center through the data center parameter. And then the keys to pull. So I'm going to pull a number of things that we're going to use for provisioning our AWS instance. Again, it isn't that this has to come from console, but I'm showing you an example of how this data can come from console. So we're pulling our subnet ID. I have this parameterized based on some variables I've defined. So the AWS region, the environment, security groups that we want to use, and I'm saying that that is app specific. And then the machine type, the machine image, right? So we looked at how that can come from AWS AMI data source, but here, if we wanted to statically define a machine image, we could do that. And then the instance types to use, right? We're going to use that for indicating the type of machine we're deploying. The root volume size, I'm setting that, the root volume type, and our SSH key, which I know I showed you through remote state, but if you wanted to declare it in console, you can do that too. So we've defined all of these different data sources, right? Let's make use of them. So we're going to provision an AWS instance, an EC2 instance in an AWS. Here, what I'm showing, what I have uncommented, is the approach of defining our AMI through data, console keys, AWS instance, which is the label we gave it, variable, and the variable name AWS AMI. Similarly, my instance type is coming from console, my subnet ID is coming from console, my VPC security group IDs is coming from console. I am using, for the key name, I'm using remote state to specify the SSH key name. And then my root volume, the volume type and size indicators are coming from console. And then I have some variables defined for indicating some tags. Please always tag your instances so that when someone goes into whatever cloud provider you're using, you're not wondering what is this thing. And I'm going to, what comes out of this? Traditionally, we do outputs, right? So I'm outputting, in this case, the public IP of our AWS instance. But let's say we wanted this data to flow back into our Consul KV store. So here's an example of what we're going to do. I'm going to place the instance ID for the instance provision, the public IP, the private IP, all of that information I'm saying can make its way into Consul. So here, because we're pushing the data, we're creating a resource. It's a resource as opposed to a data definition. So that's a whole lot of code. Let's do our let's come to our Terraform workspace, and we're going to queue a plan. Now, when we talk about doing runs in Terraform Cloud or Terraform Enterprise, there's a couple of ways that it can be triggered. if our workspace is connected to a version control system, and in this case it is, when we do a push to that repo, that VCS repo, and it could be to a specific branch. When we don't have a branch specified, it just defaults to the default branch. When we do a push or when we do a merge into that branch, that will trigger a Terraform run. So let's look at our run for the plan I just queued. I'm going to expand this so that we can look at what Terraform is going to do. So as I mentioned before, what Terraform figures out based on the infrastructure that we have declared is, what is the desired state we're looking for, and what does the environment look like, right? Oops, sorry, the plan finished. That's why that closed. As we looked at before, when Terraform does a plan, there are items that are known and there are other items that will be known after the apply. So the machine image, the AMI we're going to use, that came from our Consul data, right? The subnet ID also came from Consul. And then the volume size and the volume type for our root volume, that came from Consul. And then these Consul keys will be created as a result of our run, right? And then the other thing that Terraform, both Cloud as well as Terraform Enterprise, will give us is the cost estimation. We can build policies around this, right? So if we were to go and do something that was beyond a certain amount, that can trigger an approval requirement. And then our policy check. We have one advisory policy that we failed. That doesn't prevent us from proceeding. If we had a hard mandatory, that no way of proceeding. So, things like if you wanted to restrict in your organization the machine images that can be used, or the CIDR blocks in our security groups, you could define that. If you had the CIDR block is an example of like a hard mandatory. The machine size, the instance type, that might be a soft mandatory where you have general guidelines that are environment based, what you can do in dev versus QA versus prod. You may set those as soft mandatory, so where appropriate, they can be overridden. And because I don't have auto apply set for this workspace, I'll click confirm and that'll run our apply. So what we did up to this point was, basically the plan, right? And now we're actually making this run out in our environment. So let me go to my AWS console. I don't have, well, this is provisioning right now. It's coming up, and as Terraform does this, you'll see what ends up happening is we end up storing the state, right? So the state shows what is actually in the environment. And then when we do subsequent runs, when we iterate on our infrastructure, so we may, for example, start out with, some AWS instances. We may change that and later add a load balancer in front of it, maybe a CDN, maybe a Route 53 record. So as we iterate on our infrastructure, Terraform will figure out what it needs to change in place, what it needs to replace, what it needs to destroy, and what it needs to add. So our apply finished, and here's my output, right? So this is the IP of the instance that was provisioned. And I'll show you real quick before we go into our instance, the state, right? So there's a state history showing what was done, and the state indicates what also changed from the previous state. So my previous run was a destroy, so nothing was there after that, and this is what resulted. So let's just go into our instance. Hopefully this works. Yay, so our machine is up. That's my demo. I'd love to take questions. How are we on time?
Yeah, so now is the Q&A portion. So if you do have any questions, please submit them. So we had a few come in already. So first question, is it possible when using the Consul key provider to use mapped values?
Yeah, so that's a good question. When you say mapped values, can you, do we have interaction in terms of audio from our participants or?
No, unfortunately we don't.
Oh, okay. That is, or in the chat, I guess, in the Q&A.
Yeah, Michael Brown. Yep, he's going to type it. He said he's going to type it.
Okay, great. We can take the next question while we're waiting for that.
Okay, perfect. Okay, so is there a best practice for using remote state from one workspace in another workspace? For example, if I create a VPC in workspace A, in workspace B with its own state, I load in the VPC ARN by getting the state from workspace A. How can I make sure that workspace B would know it needs to be updated if the VPC ARN from workspace A changes? Could Consul play a part in this?
Yeah, that's a great question. So in terms of Consul, we have what's called a Consul watch. So a value changing in Consul, you can have a Terraform run triggered from that. But I want to show you something else that Terraform has, and that is the concept of run triggers. So I have here this workspace Terraform random integer, which just creates a random integer, right? I have random separator and I have random pet. And what I have set up, let me go into random separator. If I go into settings for this workspace and I go to run triggers, you see what I have set up is that when the source workspace, when Terraform run integers, does an apply happens there, right? It will trigger this workspace to plan. It won't trigger to automatically apply, even if auto apply is set, so that you don't have unintentional changes cascading. So with this approach, you might be using for your VPC workspace, you might be using Consul data. But if you're making use of data that is in another workspace, if you're using remote state, you can set up your Terraform workspace B to get triggered to run or to plan at least when there is a change in the first workspace. So I'll real quick do a run in my Terraform integer workspace and queue a plan there. It is set to auto apply, so it'll apply automatically. And I'll just come back up here and we can watch and see what happens when this finishes applying with our random separator workspace. Next question, while we're waiting for that one.
Okay, perfect. So we'll go back to the first question because he added some context. So it was originally, is it possible when using the Consul key provider to use map values? We basically have a number of environments with multiple host types. For example, in dev, we may have two hosts that are M5 large and one that is M5X large. So is it possible to use mapping and then calling them within the variables, calling their array value desired?
Yeah, let me see if we can follow up on this one. I don't have an example to show offhand along those lines, but maybe we can post something in a follow-up.
Okay. Okay.
So what happened here, our Terraform random integer finished running, and then so our random separator did a plan. And even though it is set, if we look at our workspace settings, it is set to auto apply, but because it was a triggered run, it does need to be approved. And this might happen, using a person, or might happen through your CI/CD pipeline, right? A number of our users use Terraform Cloud and Enterprise, and interact with it through the API, through a CI/CD tool like Jenkins or something. And of course, what this is going to do, there's one more workspace that is linked, and that one's running a plan now. Other questions?
Okay, awesome. None have come in so far. I'll give you guys about 1 minute if you have any additional questions for Yash. Okay, it looks like nothing so far. So thank you for your expertise on all those questions, Yash. As I mentioned at the beginning, the Hangout was recorded. So the recording will be made available on our website after post-processing, and I will also be sending you all an email to everyone that registered. If you like what you heard today and want to start exploring Terraform or Consul more, I encourage you to check out our Learn site, and you can find it on our website, learn.hashicorp.com. I hope you all enjoyed today's Hangout and have a better understanding of how to integrate Terraform with Consul. Thanks for hanging out with us today, and a big thank you to Yash for his time, and everyone have a great day. Thanks.
Thanks, folks. Thanks, Brianna.